Why behind multicast in VXLAN? This topology maybe you have seen maybe number of times, so you know about it now, right? Very simple topology. We have some leaf switches right here. We have some spine switches right here, right? And now we have two hosts, host A and host B, or server A or server B. They want to communicate with each other, and I am going to say that host A is writing ping 10.10.10.20. Same, it is in the same VLAN, and that is my problem. I know the IP address, I do not know the MAC, and that is why I'm going to generate the ARP message. The ARP message source is going to be my own address, and destination is going to be all F. You all know about it, right? And what I'm doing here is I have configured this leaf 1 that your VLAN 10 means 5010. Leaf 2, maybe this VLAN is not there at all. Suppose leaf 3, we have the VLAN number 10 and 5010 host is there, right? Now you all know what is going to happen next. This ARP message will be received by this leaf, and this leaf is going to do the VXLAN encapsulation. This leaf is taking this ARP message or layer 2 message. It is going to encapsulate it. But before encapsulation, it is going to put this VNI number in the VXLAN, right? And then it will be putting the source and destination IP. To put the source and destination IP, and by the way, guys, we are learning an important concept here, which is known as flood and learn. Believe me, although I will be explaining that concept later, but unknowingly, we are talking about that only, right? But leave the term flood and learn for now. Now, you all know that at this point of time, we know that the source is going to be 3.3.3.3. You can argue with me, Mr. Vishnu, why don't you write the UDP after the VXLAN? I can, but you all understand that there are the source port and destination port, and the source port is going to be changed on each and every message so that we can have load balancing. We have understood it. Why to create the bigger packet if we can remove it, right? All the fields which I'm showcasing you, those are very, very important in understanding, right? Now, you presume that there is a UDP header too after this 5010 VNI, right? But now let's talk about it. Let's talk about what is going to be the destination IP address. And you all know that we are dependent on this guy, this intelligent guy, who is going to tell us that basically the VNI 5010 is basically behind 5.5.5, or maybe if there is another switch here, maybe a loopback is here 6.6.6.6, which are connecting to your spines. Maybe the VLAN 10 is here also. So you need to send this message to VLAN number or VDEP 5 and VDEP 6. Were always dependent on this intelligent guy, right? Once it says that you need to send this message to two guys, we need to create two messages, believe me. And one is going to be sent to 5.5.5.5, and the other will be going to send towards 6.6.6.6, because you need to send it to everywhere where this VNI is there, right? Because our message should be going to all the VLAN 10 hosts so that we can get the reply message back, because this host 10.20 can be anywhere. You all know about it, right? But can we do something like this, right? I am throwing a challenge on you, although this intelligent guy knows everything. I do not want to take help of this intelligent guy at all. Suppose, can I do something, right, with which without taking the help of this intelligent guy, I can move this packet and I can send this packet towards 5.5.5 and 6.6.6.6. But the question arises, who is going to tell me the destination IP, right? So I am doing an intelligent thing, right? And by the way, what type of traffic I'm sending? I'm trying to send a traffic of BUM type. And inside this, specifically B, which is the broadcast, ARP is a broadcast, you all know. We have already discussed how to handle the BUM traffic in the previous class, right? One way is the ingress replication, right, which we have just discussed. The other way is, suppose what intelligent thing I am doing. I am saying, Mr. Leaf 1, you know that you have 5010 VNI, right? And you have this VTAP interface 3.3.3.3. I am assigning you a multicast address, and that is 239.1.1.1. Wherever your 5010 VNI is there, see, you are configuring this network, right? You are deciding all these things. You are saying 5010, which is VLAN 10 eventually, is actually listening on an IP address which is 239.1.1.1. What is the meaning of listening? This is the multicast group. Leaf 2 doesn't have 5010, so it is not going to hear it, right? Leaf 3, I will be saying that 5010 VNI, please listen to 239.1.1.1. Very, very interesting. And Leaf 6 also has the 5010, or means VLAN 10. It is also listening at 239.1.1.1. Very, very interesting. You have configured, you have informed Leaf 1, Leaf 3, and Leaf 4 to listen on 239.1.1.1. It means that I want to say I will be sending the ARP message which are coming from VLAN 10, which are part of the VNI 5010, which is listening at 239.1.1. It means that I am specifying wherever my VNI 5010 is, right? If my configuration is correct, and configuration should be correct, right? Because you are the network engineer, you can configure it correctly. Wherever the 5010 VNI is, I have mapped it, or I have forced it to listen at 239.1.1. Believe me, it is as good as saying that I have an RP here who is having some data for 239.1.1.1, and there are some host, or maybe leaf, right? If this leaf 1 239.1.1.1, or maybe one leaf is sending towards 239.1.1 and other are listening at 239.1.1, then definitely RP will be forwarding this traffic towards them, and only towards those leaf who are listening at 239.1.1.1. Very, very interesting, guys, right? So all these guys are actually listening at 239.1.1.1, and I am running PIM sparse mode multicast, which is very, very easy to configure. Believe me, only few commands. That's it. I will be telling you today itself. The most important piece in PIM sparse mode is rendezvous point, and I have configured those rendezvous point on spine 1 and spine 2. This is my rendezvous point, and suppose I have configured a common rendezvous point which is having only one address, and suppose that address is 1.2.3.4. And you all know everybody in the PIM should understand where the rendezvous point is, specifically in sparse mode. So I have configured this thing also in this leaf, that Mr. Leaf 1, your rendezvous point is 1.2.3.4. Leaf 2, you do not have anything, 5010, so you do not need to understand where your rendezvous point is. And for leaf 3, I have explained that your rendezvous point is 1.2.3.4. And for leaf 6 also, I'm saying that your rendezvous point is 1.2.3.4. So what is going to happen? Just try to understand. When I say this VTAP is interested in 239.1.1.1, where it is going to send a request, it is going to send a request towards this RP. I am interested in 239.1.1.1. This leaf 4 will also send a message towards this guy, or maybe this guy. I do not want to confuse you. Let the message come here, rendezvous point here, right? It means that rendezvous point knows that there are two guys who are interested in 239.1.1. And of course, this leaf 1 also is saying, I am also interested in 239.1.1.1, right? It's all about your configuration. Now, just try to think. I have to send this ARP message where? I have to send this ARP message to everywhere where this VLAN 10 is, or where this VLAN 5010 VNI is. And now I know, because of my configuration, that wherever this 5010 VNI is there, that VNI is actually listening at 239.1.1.1. Very, very simple. If that is the case, this ARP message, which is generated by this, which is at leaf, it is going to say that 5010 is the VNI, my source IP address is this, and I will be sending it towards 239.1.1.1, because I know that all of my leaves where this VLAN 10 is configured, I must be having 5010, and that 5010 must be listening at 239.1.1.1. That is why I am sending this message towards towards this multicast address, which is 239.1.1, which is eventually forwarded to all the leaves who are interested in 5010 VNI. It means that this message will flow, right? We know that if this message is generated at 3.3.3, This knows that where my RP is, it is going to forward this message towards its RP. And RP knows that I have received two requests, two join messages from leaf 3, which is 5.5.5 and 6.6.6. So I think I will be forwarding them over this 239.1.1.1 message over this tree, right? This one and this one. Will this message ever reach to 4.4.4? No, absolutely not. Why? Because there is no VLAN 10 there. Means there is no VNI 5010 there. Means that it is not listening at 239.1.1. If it is not listening, then it doesn't send the request towards the RP. And if there is no request, RP will not send it towards R4, sorry, 4.4.4 leaf, right? This message will be received at leaf 3 right here. This message will be received at leaf 4, but there is not going to be host which 10.20 IP address, which is right here. This will be sending the reply message, which is going to be the unicast. Because once this guy leaf 3 from the last discussion, it is very, very intelligent. It creates a table. It's created a table of MAC and VTAP. Once it receives this message, the complete message, it is going to see that the message came from 3.3.3.3. Once it opens the message, it will be finding that the source address of this message is AAA. It means that AAA is behind 3333, right? VTAP 333. It can make this table. And when this guy is replying, it is going to create the ARP reply message, which will be encapsulated in the MAC. The source is going to be what? My MAC address BBB. The destination will be AA, YA, because it now knows, right? The request come from AA. I need to reply to AA, and then it is going to put it. Just wait a minute, guys. Then it is going to put it inside IP packet, right? The source of this, and of course, before putting IP packet, it is going to write the PNI 5010. The source of this IP packet is going to be, of course, 4.5.5.5.5 once it is reaches here. And the destination will be, because this message wants to go to AA, the AA MAC address is behind 333. So it will be putting, this message is going to be simple unicast message. It is not a multicast message, as simple as that. So overall intent of configuring this multicast is such that you do not need to take the help of this intelligent guy. But this process is actually taking the messages and flooding it everywhere where your VNI is. But it is flooding to there only where this VLAN 10 is on the basis of 5010, which is listening at 239.1.1.1. If I say 5010 is listening at 239.1.1, I am just saying that 5.5.5 or this VTAP, this VXLAN tunnel endpoint is listening at 239.1.1.1. As simple as that. Right? Now I have been talking from last 40 minutes to just explain you why behind multicast in VXLAN, specifically for the bump traffic. I think you get it. But I can see there are two hand raises and I would love to take your questions. Mr. Vishnu, please do ask your question. Go ahead.
Yeah, hi Vishnu. So the question that I have is the VNID to multicast IP address mapping, is it manual or is it automatically taken care?
Yeah, this is very, very interesting. See, when you design a network, you need to do some IP address planning, right? When you design the VXLAN network, you need to plan it, right? Generally, people ask this question that do we have one-to-one requirement of VNI, which are for 16 millions to IP addresses, or the multicast IP addresses, which are, I think, more than 16 millions. But the problem is if you do in a scalable data center, things like this, then managing this one-to-one mapping is difficult, right? So it could be the case that your VNI 1, VNI 2, and VNI 3 can all listen to 239.1.1.1, right? Or maybe VNI 4, 5, 6 and are listening to 239.1.1. It depends on you, right? How much configuration effort you want to like. But I have seen in a scalable data center that multiple VNIs are going to be marked with only one multicast address. To answer your question, manual, yes, you need to plan it, right? But to do this configuration, you can definitely automate it once you have defined the structure. Once you have defined the logic, you can create that, of course, that these are the VNIs who want to listen to this. These are the VNIs who want to listen to this. So maybe if you have 1,000 of VNI in your complete data center, you can always specify that the starting 500 VNIs are going to listen at 239.1 or whatever the scheme you would like to do. Right, Vishnu?
Yeah, but Is it not a security issue, Vishnu? Because here we are clubbing different VNIs to listen to the same multicast address.
Yeah, we need to. That is why we need to plan. See, basically, I can say that you should not send it to other customer environment, right? If you have customer A, then you must be having the VNI for customer A, right? If you're having the customer B, you must be having the VNI for customer B. You make sure that the customer A, right, multicast addresses or VNI should remains here, right? And customer B should remain. And that is what we need planning for, Mr. Vishnu.
Okay, cool. Thanks, Vishnu.
Perfect, perfect. And it's a great question, by the way. Now let's move towards Mr. Supreet. Mr. Supreet, you can ask your question. Please go ahead.
Hey Vishnu, thank you. So just a confusion over here. So what's the exact RP? Is it 1.2.3.4 or it's 239.1.1.1?
See, RP, Mr. Supreet, is actually your unicast address, right?
Right, exactly, yes.
Yeah, so there is anything which you can configure which can identify this router. And what I'm doing here is I am identifying, I have created 1.2.3.4 loopback here also, and I have created 1.2.3.4 loopback here also. By the way, this concept is known as Anycast RP because you have two IP addresses configured on different routers, which you can do, right? This is /32. Once you are running your your unicast routing. Okay, I will be explaining this topic. Do not worry, Mr. Supreet. So right now, this is the IP address, unicast IP address. This is not the multicast, right?
Okay, yep, got it.
Now, Mr. Gomati, please ask your question. Please go ahead.
Thank you, Vishnu. So the first question is actually, how do we migrate the existing data center setup, which is running traditional VLAN to VXLAN?
Generally, we create the parallel network and we shift the VLANs, right? But there are multiple approaches of doing that. Maybe these leaf switches and you already have Nexus switches. You just need to upgrade who can support the VXLAN, right? And in that case, it needs the downtime. So migration strategy could be different, but that is going to take some time to explain you. Believe me. We are just understanding the fundamentals now. Once it is done, maybe we can discuss in some class little bit of migration strategy too. Okay.
Thank you, Vishnu. And thank you. Second question, Vishnu. So what will be the connectivity between the spine 1 and spine 2? Is that a layer 3 or is that a VPC, or what will be the communications between the spine 1 and spine 2?
The spine 1 and spine 2 are there is no link directly connecting them. I do not have any link connecting them.
Correct.
Yeah.
So don't we require any connectivity between them?
See, these are just my just try to understand. When we were discussing about spine and leaf topology, I mentioned you that these spines are just like any router, which are getting the IP packet and just forward them as soon as possible on the basis of IP, right? They do not need any connectivity between them because I have connected a leaf, and this is very, very special architecture, believe me. From any leaf, at the end of the day, what do you want to do? You need to communicate leaf 1 to leaf 2, or maybe leaf 3, or maybe anything, right? These are this is the communication you want, right? And you want it to be absolutely simple. And that is why you required one more layer, which is actually to any layer. If you want to go from leaf 2 to leaf 3, you have only one hop in middle. So in the last class, we discussed about it. Why?
Yeah, correct.
Yeah. Why basically spine and leaf? Why this topology is creating so much of value, right? And believe me.
I understand that is all from the east and west traffic, but what about the north and south traffic? If you get the real data center scenario,
yeah, very, very interesting. Yeah, so, and those real things, right? We will make these leaf as the border. We do not want to connect these spines to somewhere, and I will tell you the exact reason. Where this leaf is going to be the border, and it is going to connect to a real router, which may be on internet or maybe on MPLS. Okay.
Okay. So what is the reason?
The reason is, see, here basically the rendezvous point is, this spine is seeing just the normal IP packets, right? But do you think that these packets want to communicate 3.3.3 or 4.4.4? Who is actually communicating? This guy, at the end of the day, this server will be communicating to outside world, or somebody from outside will be communicating to 10.10.10.10. You agree with me?
Okay.
Right. But what does spine see? This spine see the IP message from 3.3.3.3 towards maybe 4.4.4 or 5.5.5. They do not see the exact underlay message, right? You forward on the basis of this. When the message reaches here on 4.4.4 or 5.5.5, these guys are decapsulating it, right? These guys are seeing the message, real IP message, which is from here to here, the overlay message, right? Because what you are doing, this host message is your overlay message, which is going over this underlay, and the spine is part of underlay, right? It is not the case that you cannot do it, but you need to add some functionality to spine to open this message, right? Which you do not want to do. Spine is basically something which is taking the IP address, IP packet, and forwarding it everywhere, right?
Okay.
Now leaf 2 is going to have the real IP message from 10.10.10.10 towards maybe internet. Believe me, I will be covering how you are going to connect your data center to outside world.
Okay.
Okay. But it's again a wonderful question. And this question should be in your mind, that why we are not connecting these spines. We can connect these spine to directly router, right? But you need to spend some time on this spine. You need to tell that, Mr. Spine, you need to decapsulate the packet and then send it, right? Which is anyhow happening at the leaf. So we will be connecting the leaf. Maybe this leaf is strong enough to connect to the outside world. Maybe we can take the powerful leaf here, which can be our border leaf. Okay, Mr. Gomti?
Okay. Yeah, thank you. And one more, sorry, last question. So we are doing now with the multicast VXLAN, multicast topic. But are we going to cover it with the ingress replications?
Yeah, ingress replication approach is slightly different. Ingress replication approach, basically you tell them by list that you need to send this message towards 4.4.4, 5.5.5, and 6.6.6. And that is why this guy is going to create 3 different messages and then it's sent. But this is not the optimal way of doing it, right? If you have a huge data center, you should have the multicast to handle the bump traffic. Okay.
Okay. Yeah.
Yeah.
I'm just thinking because the configuration perspective, which one is a, see, for example, we have a simple data center. So is that still we need to configure on the multicast?
No, you do not. You do not need to. You just configure the ingress replication. I can give you the configuration for that, right?
Okay.
It is up to you. It is not necessary. Means if you are using ingress replication, believe me, you do not need to configure multicast at all, right? People have some fear of multicast technology, and that is why. But believe me, multicast technology is one of the simplest one, right? One of the simple technologies.
I understand.
And Mr. Rahul has mentioned the clause topology, and that is basically with the name of Mr. Claus, who was in the era when people were actually busy in communicating over these telephones, right? So he has developed a clause topology, and believe me, all the switches and routers are basically building this topology, and your spine and leaf is one of them. So just read about Mr. Claus and Mr. Claus topologies, and you will be finding some good information. Thank you so much, Rahul, for informing me in chat.